got my son, Chris, right here.
Yeah.
He asked me to come in and talk to you guys today. I am a manager for Arcelor MIttal. It's the largest steel manufacturer in the whole entire world. You've heard of like Fortune 500 companies. Arcelor MIttal is actually a global 100 company, which is one of the 100 biggest companies in the whole entire world. I'm sure, let's see, does anyone here have a family member that works at the steel mill? Raise your hand. An aunt, an uncle, a grandpa, a dad, a mom. Okay, any other job you think of for one single company, I bet we couldn't get that many hands up in a room. That's how important steelmaking is in Northwest Indiana. I'm going to play this short video for you guys first, and you guys can ask me some questions, and then I got one more video.
Arcelor MIttal.
Arcelor MIttal.
That's what I thought.
Arcelor MIttal.
Beauty products.
No idea. Marketing?
Accounting.
Is it something with computers or software?
Mining and metals.
Made of steel.
Maybe your refrigerator, appliances, pots, pans, maybe?
We have shelves in our house that are made of steel.
Superman.
The railroad stuff comes to mind. Ships.
Bridges.
Machinery?
I play guitar and my strings are made of steel.
I guess you could have a chair.
Countertops, jungle gyms, chairs, doorknobs, buildings, cars, the list is going on.
Probably like 30 to 35,000, possibly.
50,000?
On average, 60K a year, 40,000 a year.
I'm not sure.
Maybe 90,000 a year?
$90,000 a year? I'm retired. I missed the boat.
Wow. That's awesome.
Are you serious? Oh my gosh! I had no idea.
Okay, so I'm doing something wrong.
Strong. Strong.
Productive, cool,
Useful.
strong,
Necessary.
Important to the U.S. economy.
Arcelor MIttal.
Arcelor MIttal.
Arcelor MIttal.
Arcelor MIttal. This is us.
This is us.
This is us.
Alright, so I work at the Burns Harbor plant, which used to be called Bethlehem Steel. Just in this area here, we own multiple other plants that used to be called other things. I'm a 4th generation steel worker, which means that my dad worked at the steel mill and retired. His dad worked at the steel mill, and his dad worked at the steel mill. So my family's worked in the steel mill pretty much probably since my ancestors immigrated here. So we've been here since the start of the steel mills, working at them. I never thought I was going to work in the steel mill. When I was a kid, I was always like, Dad, I'm never going to be out at the steel mill. You know, I just wanted to video games, and maybe do something with that, you know. But then I started realizing, wait a minute, I have no money at all. I'm gonna need to do something to get some money. I ended up, after high school, I didn't do very well in high school. So after that, I didn't have many choices. A lot of my friends went off to college. I ended up leaving and going to the military for 5 years. And I served overseas. I was in the United States Navy. I was aviation. I used to fix helicopters and fighter jets. And then after that, I came home and I used my GI Bill and I went to college. And when I went to college, I did really well. I graduated with honors, and I used that degree to get a manager position at the mill, which I've been at for about 7 years now. I've lived in this area since I came home. I'm from this area before I left for the military, so I lived in Northwest Indiana. The steel mill is separated into multiple different areas. It's a big process. I'll show you guys a video in a minute that shows from start to finish the whole process of making steel. It's a huge process. I'm a manager of one line in this process. It's called the hot dip coating line. And what we do there is, this line is about over 1 mile long, and the steel runs through it almost like a maze. It runs through this gigantic furnace that gets over 1,500 degrees. It runs through that, and then it comes out and goes through a giant molten zinc pot, which you'll see, it's like a big, huge tub of molten, melted zinc metal, and it's silver and shiny, and then the strip comes out of that, and that's coating the steel. The biggest reason we do that is for automotive. A lot of the steel that I make where I'm at is for cars, also like dishwashers, Whirlpool, John Deere, big companies like that use it. Let's see what else here. Do you guys have any questions before I show you guys how we make steel?
Where do you get the steel from and then you make it again?
We actually start from nothing. We mine the earth for the minerals that we need, and then we make it out of pretty much nothing into steel. And after it's been made, we can reuse it over and over and over. Steel is one of the only things that can be recycled pretty much forever. We start off with some metal that's like old cars or old anything steel, and we put that in the mix, and we can do that forever. So say a car that, the first car ever made, if that was recycled, it could still be in things that are being made with steel now. It recycles forever.
How long does it normally take you to find the minerals that you need?
To what?
To find the minerals that you need to.
There's like, Arcelor MIttal owns all these mining companies all over the world, and their mines that have already been found, they know where these minerals are at, they do testing to find them, and then, since they already own the mines, they're already there, so it's really easy for them to get the minerals out to, and then they send them wherever we need them. Anyone else? I do not mine, no. I'm not a miner. All the mining operations are overseas. So we don't actually do any mining in Northwest Indiana. The materials that are mined that we need are sent here by ship, which is one of the reasons why you see that all the steel mills are right on the lake there. That makes a really good, easy access point for us to get minerals in and to ship steel out. It's just one of the reasons why Northwest Indiana is such a giant hub for steel making. The what? Big cargo ships? Yeah, but you still can, because what happens is we take that rust and it gets burned off. We burn off all the impurities because it gets heated so much to make steel, which you'll see that it burns everything that's impure about the steel off. All the rust just burns right off. Someone else had one?
What do you guys use to dig?
To dig? Oh gosh. They have, I don't even know what they're called. They have these huge, kind of like drills. They have huge ones. All different, gosh, I wish I could remember what it's called. They have these, they're like giant machines, and they dig at the earth and they mine with those. Yeah, I can't remember what they're called. Like I said, we don't do any mining here, so I'm nowhere near the mining process. Anyone else? Yeah?
Do you normally have to melt the old steel that you mix with the
Yes,
fluid?
everything gets melted down and started over. We never take steel that's just crushed up and then use that. It all gets melted. When you see the process, it all gets put together and melted together to make brand new steel.
When you go for like the digging, or not the, I mean the mining,
Yeah.
do you ever, has somebody ever got stuck with something?
The bad thing about steel making is the fact that it's very dangerous. And we do, being such a large company, doing something so dangerous, people do die. And mining is a big area where we do have fatalities. Last year we had a couple steel workers pass in Northwest Indiana. So it does happen. It's very dangerous. It's not for everybody, but it's so important to have this steel and be able to make it here that we do everything we can to try to make it safely, but there's sometimes things happen that we can't control that could cause people to get hurt or killed. All right, one more, and then I'll start this video.
You have to go through security to get to your job?
Yes, like if I had a car and like I put you guys in it, they wouldn't let me inside. We all have a badge that we have to swipe in, and there's security at the gates, so we can't bring people inside there. Our 50th anniversary was a couple years ago, and they did a family day where people could bring their families in. So sometimes they do stuff like that, but on normal days you can't just go in there. So I'm going to show you guys a video, I think it's like 10 minutes, and it's going to show the whole steel making process from start to finish. If you see something in there, try to remember it and then ask me afterwards, and I'll try to answer everything I can. Like I said, I just went with one aspect. I'll try to answer questions for the whole process if anyone has one. Can you guys see this okay?
Yeah.
A little, me too. All right, here we go.
And dream. It carries the weight of our highest aspirations and moves us through life. In it we see ourselves, using it to express who we are and what we dream. Rock, heat, and raw power are combined with innovation, inspiration, and the latest technology to produce a product that is transforming customers require. Many customers also request steel that has been coated. To do this, the coil runs through a zinc bath. The steel is run through liquid zinc in a bath that is about 800 degrees in temperature. To keep the liquid clean, a robot is used to continuously skim the surface of the zinc.
We got a robot.
After the bath, the steel is formed again into a coil. When the coil is finished, it may be wrapped and then moved into storage until it is shipped to the customer to take on its new form as your car, dishwasher, artwork, or any number of things you use every day.
I was like right behind the camera.
Throughout the steel-making process, products are monitored with strict quality control methods. Samples are taken, and quality is monitored by experienced technicians and engineers. The steel industry has always been a force in driving society forward. To do this, the industry relies heavily on research and development to find innovative ways to meet evolving customer demands and offer new product applications. Researchers are also looking to improve the steelmaking process itself. One key goal is to reduce the environmental impact of steel manufacturing. Water and air treatment facilities located in the mill are continually improved, and nearly 50% of today's steel output comes from recycled scrap. The steel industry has a proud past and a bright future, and is forging ahead to a tomorrow that is both economically and environmentally sustainable, so that steel continues to provide the foundation for so many products and the inspiration behind so many possibilities.
That wasn't 11 minutes, was it?
No.
Something, man. We must have skipped. Did we skip it?
Steel, it's the
Where we were at.
rail. The iron ore arrives at the steel mill. Bone of our modern rock, heat, and raw power are combined. Steel's applications are limitless, and its effects are everywhere. But how do we get from this to this?
A lot of explosions in the mining process.
It all begins here, at a mine like this one in northern Minnesota, where precisely timed explosions are used to free a rock called taconite from the earth. The taconite is then processed into iron ore pellets. These simple-looking pellets become the base material for one of the world's most versatile and important products, steel. Each day, a mine like this can process 125,000 metric tons of iron ore. From the mine, via freighter or rail, the iron ore arrives at a steel mill. Integrated mills may cover several square miles. At the mill, the ore is offloaded from the freighter. Massive machines, known as stacker reclaimers, are used to move the ore into huge storage piles. The mill will draw from these stores to produce steel year-round, 24 hours a day. Another essential input for steel making is coal, but for coal to be used, it must first go through a process known as coking. To turn coal into coke, it is baked for 18 hours in a row of furnaces. This renders the coal much more efficient for the steel making process. Once the coke has been baked, it is pushed into a car and moved to a quenching station, where it's doused with water to cool it down, creating a tremendous amount of harmless steam. The cooled coke is dumped onto a conveyor system that brings it to storage. The iron ore pellets, coke, and also limestone all end up here in the blast furnace. This is where the raw materials first become hot metal. Modern blast furnaces are massive and highly automated. A blast furnace may measure 317 feet high, reach temperatures of 4,000 degrees Fahrenheit, and produce 13,000 tons of liquid iron a day. Iron ore pellets, coke, and limestone are transported to the top of the blast furnace and are dumped in. Technicians in a control pulpit carefully control the amount of each material entering the furnace. Superheated air is pumped in near the bottom of the blast furnace. The heat causes chemical reactions that draw the iron from the ore. Fuel and carbon are provided by the coke, and limestone draws off impurities. Gravity draws the liquid iron, referred to as hot metal or pig iron, to the bottom of the furnace. Impurities rise to the top and form a substance known as slag. When enough hot metal has collected at the bottom, the blast furnace is tapped. A robotic arm drills out a clay plug in one of up to 4 tap holes in the furnace. This allows hot metal to flow into a trench that leads to rail cars known as bottle cars. Slag flows to another area where it is cooled and collected. Slag used to be a cumbersome byproduct of steelmaking. Now it provides a whole new market, as slag is sold for applications like paving materials and concrete. The molten iron that comes from the blast furnace is not yet steel. Its carbon content is too high, so it is transferred in the bottle cars to the steel making facility. Here, the hot metal is poured into gigantic ladles that hold up to 305 short tons. Sulfur is inserted for a chemical reaction to draw up more slag, and the ladle is positioned for a robot to scrape off the slag. Once this is done, the ladle is ready to be transferred to the basic oxygen furnace to become steel. Before adding the hot metal, the basic oxygen furnace is charged with a load of scrap metal. An overhead crane then picks up the ladle of iron and brings it to the mouth of the furnace, where it is poured in over the scrap. The furnace moves to its upright position, and an oxygen lance descends. Pure oxygen is blown into the mixture to cause a volatile reaction that reduces the carbon content of the hot metal, transforming it into molten steel. Alloys may also be added to customize the structure of the steel to a customer's specifications. Steel is the most recycled product in the world. Along with being used to charge the basic oxygen furnace, scrap is melted directly into new steel in what is known as an electric arc furnace. Loads of scrap are dumped into the top of the furnace and heated up to 3,050 degrees Fahrenheit. Impurities burn off and new steel emerges. Whether produced from new ore or recycled from scrap, the molten steel's next stop is casting. There the steel is drawn from the ladles and formed into a slab or billet. The shape is determined by what the end product will be. Slabs may become a coil of thin steel. Billets may eventually end up as rods or cable. Modern casting is continuous, so the steel is cast in an ongoing flow onto the line. At the desired length, gas torches make a cut to produce an individual segment. After cutting, the steel is collected and stored until it's ready for primary forming. At primary forming, the steel begins to take on the shape the customers have ordered. In the case of flat products like these rolls of steel, slabs go to a hot rolling mill. The slab is first reheated in a furnace to make it pliable for shaping. Then it goes through the descaler to knock off any impurities from the surface. After that is done, the red-hot slab runs through a series of rollers to flatten the steel. Each roller brings the steel closer to its desired thickness. It may go from a slab that was 31 feet long to a roll of steel that is 3,191 feet long in 3 minutes. The continued lengthening means that while the slab enters the line at about 2 miles per hour, by the time it reaches the end of the rollers, it is moving at 36 miles per hour. The ribbon of steel is then cooled with water and rolled up to huge coils. Long products like bars or cable are made from a billet that is first heated in a furnace. At 1,800 degrees Fahrenheit, the steel becomes pliable and is run through a series of shaping points on the line. The process can be adjusted to meet the desired end product thickness. When the process is complete, a 40-foot 7-inch square billet may end up as a 1,000-foot half-inch steel coil or series of bars. After primary forming, the steel is further treated to meet end product requirements. Flat products go through a cold rolling mill. Here, the raw coil is placed on the line. Coils are welded together end to end to produce a continuous ribbon of steel that runs through the whole process. First, the steel runs through a pickling process that uses hypochloric acid to eliminate any exterior corrosion or blemishes. The steel is then run through a series of rollers that reduce the steel to the desired thickness. Steel at this stage may enter the mill at 1/10 of an inch thick and leave as narrow as 2/100ths of an inch thick. At this point, the steel is too brittle for most applications, so it goes through an annealing process. Modern continuous annealing takes place in a series of furnaces several stories high. As it runs through the furnaces, the steel is heated up and then quickly cooled to lock its molecular structure into one that allows for the flexibility most customers require. Many customers also request steel that has been coated. To do this, the coil runs through a zinc bath. The steel is run through liquid zinc.
So I work in the cold mill, in the finishing department, and that's where we get the steel when it's already in the, shape of a coil, and then we'll run it through the furnace to anneal it, which gets the metal to reach whatever properties the customer needs it for. So say if someone's making a car, they need, say the hoods can be a little bit more flexible, so that'll be treated at a different temperature than say steel that they use to make some sort of brackets or parts of the frame. That those will need to be harder, so those will be heated at different temperatures to make sure that they are what the customer wants. Yeah.
Did you say you worked at the old Bethlehem Steel plant?
Yes, it used to be called Bethlehem Steel. Arcelor MIttal bought it, and so it's just called Arcelor MIttal now. But yeah, it used to be called Bethlehem Steel in Burns Harbor.
That's cool. Didn't it catch on fire once?
Yeah, in gosh, probably before you guys were born.
That's cool.
Yes. Anybody got any questions? Yeah. It's actually molten steel, but it looks like lava. So because it's all red like that, it looks like it would be lava, but it's actually just metal before it's formed to look like something else. Yeah.
So you guys, were those sirens you guys use it?
Yeah. Anytime anything dangerous or really hot or anything that can hurt somebody and is moving, then they'll have some sort of siren, something like that. It's really loud where I work. I wear hearing protection, and a lot of the guys that retire, even with hearing protection, a lot of them have like hearing aids now. It's really loud there. Water? Oh gosh. I can't remember what it is, but we use so many gallons per ton of steel, and it's a lot of water. But we have a water treatment facility on the plant, and after we use the water, we retreat it so that it can be used again or put back into the lake. It's not that the water is used and then gone. Because if it was, the Lake Michigan would probably be dry by now, because we use so much water for the cooling process and the steel making process and all together.
Is that why well water tastes like?
No, unfortunately, no, that's not why. But that makes sense because it tastes like sulfur in eggs. But no, that's not why. But if you swam in Lake Michigan before, it doesn't smell like well water, right? So that would be the water that we use out of the lake. But yeah, I don't. Well, water just smells like that. Yeah.
Like sometimes when you drive by mill, there'd be like fire.
Yeah.
Like there'd be like a fire on top. And my dad worked at a mill, and he said that even when it rains, it doesn't go out.
Nope. So you're probably talking about my mill. There was actually something in the paper about it because everyone's like, "What is this fire that's burning?" Everyone can see it in the town, and they call it the Northwest Indiana pilot light. And what it is, it's burning off impurities that if we weren't burning that, it would be letting these impurities into the air. And if we burn the impurities, that would be dangerous to the environment by letting these gases and stuff into the ozone. But they're actually working on replacing that so that we won't have to burn it anymore. There's a new process that we're working on so that we won't have this huge giant flame burning out of the top of the mill when people drive by. Yeah.
Alright, so like sometimes if I want like to go somewhere in the car, I see like mills of things, like the thing that lights stuff, is that like steam?
Probably steam, probably steam. Yeah, almost like cloud making. Or I'm sure you see a lot of trucks with coils on the back all around here. Those come from my line. Yeah.
When you guys are burning stuff, is there like a lot of smoke that comes out?
Yeah, but a lot of it's controlled to where there's not as much smoke as you think because some of it's done inside. So they have ventilation systems set up so it wouldn't be as smoky as you would see like a bonfire or something like that.
When I drive by Syracuse and all I see is
Yeah, mostly you'll see steam cars. We have really strict regulations to protect the environment so that we don't, it's not that bad when you go by us. Yeah?
Is your job hard to you?
Is it what?
Is it hard?
Yeah, I have really hard days out there sometimes. Some days are, so we have good days and bad days. If everything's going well, it's usually a good day and it's not very hard. But then if something breaks, then it can turn into a really bad day where we might be working on our feet for 12 hours a day trying to fix something. We get dirty, people get hurt, but a lot of the days aren't bad. If it was that bad, then there wouldn't be so many people working there because everyone would want to work there if it was too bad. Go ahead.
Like my grandma used to work, I think at steel, steel mill, he retired because I was driving a bulldozer, I think he was pushing steel, I think, and on top of that, his eye just got a little bad, and then Daddy,
Yeah, most people who've worked there their whole life end up getting some sort of injury out there or hurt in some way.
Never just got blind.
Yeah?
Do you have to have permission to borrow water
There's something set up, which, I'm not a big part of that part of it, but there's something set up with the way that the water usage is dealt with, and then how it's put back in the lake. There's a big process set up by the EPA that I don't know a lot about, but yes.
What's the smoke by the one that's the smoke where it stays there and it doesn't move by the mill?
Oh, I'm not really sure. It might be steam. I'm not 100% sure. I'll look next time I go.
Okay.
Next time I go to work.
Okay.
Why do people suddenly join this job?
Why do they what?
Why do so many people join this job if it's that dangerous?
Enjoy it? Well,
No, join.
Join?
Yeah.
Why they get a job there?
Yeah.
Well, because everybody wants to, all your parents and family members, they want to get a good job to where they can provide well for their family. And even though it's dangerous, parents and stuff will do things like that so that they can provide a better life for their kids and their family. And this is one of the highest paying jobs in this area that people can go to and work, and some of them can do it without a degree. I need a bachelor's degree for my job, but the workers that work for me, they don't need a bachelor's degree. So it's a high paying job. Yes, it's dangerous, but people that might not have a college background can make really good money doing it. So it's like a risk reward trade-off. Yeah?
Do you wear protection?
Yes, I wear PPE every day. I have to wear steel-toed boots, pants, long sleeve shirts. I have a hard hat, safety glasses, hearing protection, gloves. Have to be worn at all times. We just started wearing their sleevelets, and they're cut resistant because people were getting cut really bad. So we wear the sleeves underneath our shirts. And then if you work by the molten metal, you wear these protective jackets that are like silver, and they can withstand a certain amount of heat.
Has anybody got burnt by the lava or that lava?
Yeah, the zinc, people get burnt out. People get burnt on my line. Will you let me know when I got 10 minutes or 5 minutes or something?
You have about 5.
5, okay. Yeah, people do get burnt there because sometimes it splashes and gets really hot. But I did bring a bunch of stuff to give you guys from the mill. You guys like free stuff?
Yeah.